What's going on, Netscape? Today we're going to derivative again with the hyperbolic and inverse hyperbolic derivatives. Now I've packed all of these in one video so we can complete this as soon as before finals week arrives. So yeah, and all of these things are in the video. So here are the hyperbolic and inverse derivatives as well as the identities most commonly used in here. So if you want to use that, you may look into it for future reference. But with that out of the way, the file is in the description once again. So if you need to answer alongside me, there's you can have the file there. All right. All right. Let's go to question number one. Uh, one. Y is equals to the hyperbolic sine of x. We need the 20/23 derivative. So that's a lot of derivatives to do, right? But as we discussed earlier, as we saw here, sinh of x, this derivative is cosh. For cosh, its derivative is sinh. So it just goes back and forth. So we just need to know if the 20/23 derivative is sinh or cosh. So sinh, the first derivative is cosh. And then the second derivative is sinh. The third derivative is cosh again. So there's a pattern here. Odd numbers, that is equals to cosh of x. Even numbers, even places, even derivatives is equals to sinh of x. So 20/23 is an odd number. An odd number. So the answer is equals to cosh of x. That's it. Next. Question number 2. Y is equals to the hyperbolic tangent of x. Now, if you remember from trigonometry, tan x, its derivative is secant squared x, right? In hyperbolic trigonometry, something similar also happens where in hyperbolic tangent, it is equals to secant hyperbolic secant squared x. So that is also the derivative. It's something similar. So we can use the chain rule here to solve this. This is the outer, this is the inner. So we get y prime is equals to 2 tangent hyperbolic tangent of x to the power of 1, but that is so you don't need to write that. And then secant squared hyperbolic secant squared x. Rearranging, we get 2 secant hyperbolic squared x tangent hyperbolic x. That is the second answer. Number 3. Y is equals to hyperbolic cosecant of 3e to the x. Oh, sorry. 3e to the x. And we need to find slope at x equals 0. We need to find the derivative of this first, and then we can find if we can find the slope at 0. So let's see from the list again. So for cosecant, it's going to be negative cosecant x negative hyperbolic cosecant x hyperbolic cotangent x. So we're going to use that. So y prime is equals to negative hyperbolic cosecant and then hyperbolic cotangent. We can put the input here and the input here. Then we multiply by the derivative of the input. What is the derivative of e to the x? It's e to the x. 3 is just a constant multiple, so we can multiply it here and then e to the x. And then let's rearrange this so it looks proper. Negative 3e to the x hyperbolic cosecant of 3e to the x hyperbolic cotangent of 3e to the x. Now how do we do this? So we know that we need x equals 0, so let's put that first. This is y prime, so let's find for y prime of 0. This is now equal to negative 3 times e to the 0 hyperbolic cosecant of 3e to the 0 hyperbolic cotangent of 3e to the 0. This is going to be negative 3, then cosecant hyperbolic of 3, hyperbolic cotangent of 3. Now, how do we do this? You can use the calculator if you're allowed, but if you're not allowed to use the calculator, you could use the definition of hyperbolic cosecant and cotangent. So what is that? So let's recap. For sinh of x, that is equal to e to the x minus e to the negative x over 2. For cosh, it's the plus version over 2. Let me just check. Hold on, let me just make sure this is correct. Okay, that is indeed correct. So what we can do is to find hyperbolic cosecant, we just flip this on its head. Since hyperbolic cosecant is the reciprocal of sinh, uh, we can also find the reciprocal of this in order to get hyperbolic cosecant. So it's 2 over e x minus e to the negative x. Now for for cosh or hyperbolic cotangent x, we know that is cosh x over sinh x. This is very similar to the one in normal trigonometry or circular trigonometry. So cosh x over sinh x. Cosh x is this, so we get e to the x plus e to the negative x over well, hang on, over 2 all over e to the x minus e to the negative x over 2. We can cancel the 2's here, and then we get e to the x plus e to the negative x over e to the x minus e to the negative x. So what can we do with this one? Well, we know the representation of the value within cosh. So hold on. Let's try substituting everything here so we can find an exact value. So y prime of 0 is equals to negative 3, and then hyperbolic cosecant is this one, so let's input 3 in x, so we get times 2 over e cubed minus e to the negative 3. For cotangent, it's the same thing. Let's just put 3 in this x, so we get e cubed plus e to the negative 3 over e cubed minus e to the negative 3. So that is something indeed. But let's try simplifying it even further. So we can multiply both the numerator and denominator by e cubed. As well here, we can multiply that. You'll see why later. So we get negative 3 times 2e cubed times, then we get e to the 6, 3 plus 3 is equal to 6, so there we go. Then negative 3 plus 3 equals 0, so that's going to be e to the 0, which is going to be 1. Alright, over the bottom here we get e to the 6 minus 1, and then the same thing happens here, so it's a squared here. So that can be your final answer. Let's try using the calculator to find out what that is. Negative 3 times 2e cubed times e to the 6 plus 1 divided by e to the 6 minus 1 squared. The answer is around negative 0.300953. That is the calculator answer, but that is the more accurate answer. So yeah. Hold on. Okay. y is equals to AR such area hyperbolic secant of x squared. Let's look at the list yet again to find out what we need to do. For hyperbolic secant here, inverse hyperbolic secant is going to be negative 1 over x square root of 1 minus x squared. So let's do that. So y prime is equals to negative 1 over x squared, the input here, then square root of 1 minus x squared squared. Is that correct? Let me just check. It is, yep, it is correct. Okay. And then we multiply by the derivative of the inside, the chain rule. So we get multiply by 2x. The derivative of x squared is 2x. We can cancel the x here, the x here. So we get negative 2 over x square root of 1 minus x to the 4. That is our answer. Now, before we proceed, you can see here, I pulled this from the internet, that there are restrictions on what x could be. This is fine because we are dealing with indefinite derivatives, so nothing really important there. But if you're trying to find, for example, derivatives, maybe maybe derivatives of the like the slope, then it asks for something that's impossible. Maybe that's not a thing. So for example, in here x should be less than or equal to, no, that's less than 1, because if x is greater than 1, then the bottom would be either 0 or imaginary, which is not allowed. So that's the reason why there are bounds on the list that we are using. Question number 5. I'm looking at the list. Question number 5. Okay, the y is equals to the cube root of cosh of x cubed. Yes. So what we can do here is just the chain rule. Just the chain rule. Just repeat the chain rule. So let's format it into something that's much more consumable. So cosh of x cubed, and then to the power of 1 over 3. The cube root is equivalent to the power 1 over 3. So it's the same. So the outside function is this one. Then next is this one. And then next is this one. So let's start at the outside. Y prime is equals to, bring the power to the side, 1/3, and then raise this to the power of, hold on, raise this to the power of negative 2/3. Alright? And then we multiplied by the derivative of the inside. So that's going to be sinh of x cubed. Then we multiply by the derivative of the inside yet again, which is going to be 3x squared. So, anyway, I just got a bit confused. Anyway, so what we're getting here is sinh x cubed, then like 3x squared here over 3 times the cube root of cosh of x cubed, and then squared, since there's a 2 in the top. So that is, we can still cancel this out. We get x squared sinh of x cubed over cube root of cosh squared x cubed. That is our answer. Question number, hold on. Question number 6. Y is equals to cosh power 4 of x minus sinh power 4 of x. So in here we can you could use the we could brute force it. It's quite easy, but we need to find the third derivative. So in this case, it's going to be hard to just brute force this entire thing. So no brute forcing for us. We need to simplify this further. So what can we do? So notice to the power 4 to the power 4, and there's a minus here. This looks like as a difference of two squares situation. So remember difference of two squares. So x squared minus y squared, that's going to be x plus y, x minus y. Right? That's easy. That's easy enough. So let's apply it here. Cosh to the power 4x. This is the same as cosh squared x squared. Let's erase this one. And then minus sinh squared. Hold on. Load. I apologize. Sinh squared and then of x, this to the power of 2. Now that's a difference of two squares now, so let's simplify this further. So cosh squared x minus sinh squared x, 6. No, not 6. The Photoshop just got wonky. Anyway, sinh squared x and then minus no, not minus, just plain multiply. So cosh squared x plus sinh squared x. Jesus. Hold on, let me just, yeah, anyway. So sinh squared x. This from what we saw earlier was 1. It's different from the normal trigonometry in where it's cosine squared plus sine squared, right? In hyperbolic, it's cosh squared minus sinh squared. So it's the minus one that gets the Pythagorean identity. Moreover, the plus version of this is now cosh of 2x, as we discussed earlier in the list. You can look at it if you want. So this is going to be 1. This is cosh 2x. This is just going to be cosh of 2x. We need the third derivative. So y prime is equals to, well, sinh here. Sinh here, 2x. Then multiply by the derivative of 2x, which is going to be 2. Y double prime is going 2 times then cosh of 2x. Then multiply by 2. The derivative of 2x. So we get 4 cosh of 2x. Now for the final one, the triple prime of y is equals to 4 times 2 is 8, then sinh of 2x. That's the answer. It's a good idea to simplify it before doing anything else. Here's a hard one. Ooh. Arc tangent xy is equals to AR, area hyperbolic tangent of xy. This is inverse hyperbolic, so don't need to worry about that. So arctan xy, we know the formula for arctan is the derivative, at least, is 1 over 1 plus x squared y squared. This is the square of xy multiplied by the derivative of the inside. What's the derivative of xy? The derivative is going to be 1, and then this is going to be y prime. Cross multiply, we get y times 1 plus x y prime. That's it. It's equals to AR tanh. So it's going to be a bit different here, but it's just going to be 1 minus x squared y squared. So it's not that big of a difference, but it is something. And the derivative of xy is, as we discussed earlier, y plus xy prime. So it looks a bit familiar. So let's erase this one first. Let's isolate everything with y prime to one side and y to the other. So let's put xy prime And then what has xy prime here? For this one is 1 over 1 plus x squared y squared minus over here we transpose it to the other side, so 1 over 1 minus x squared y squared, right? Then we get the next one. We put everything that has y to the other side. This is not going to fit, so let's put it to the bottom. Hold on, let me just do this. Okay, and then this is going to be, let's say, y then multiplied by what's going to be here. First is going to be this one, minus x squared y squared minus 1 over 1 plus x squared y squared. Now, did you notice anything good at all? Look, this one and this one is just flipped. It's just flipped together. So this one is the 1 plus is here, then the minus is here. Minus is here, plus is here, and then there's a minus sign here. We can cancel them out, and then we can cancel each other out actually, and then we will end up with -1 here. It's going to be -1 if we cancel this out, and then this one is going to be +1. So we get xy prime is equals to -y. That easy, right? And then y prime is equals to -y over x. That is our answer. It's that easy. Y is equals to sinh of ln x. Now, before you do your chain rule situation, which you can absolutely do, let's do something more interesting here. We know sinh of x is e to the x. Sinh of x is e to the x minus e to the -x over 2, right? So let's put ln x in the input. So sinh ln x, so y is equals to sinh ln x is equals to e to the ln x minus e to the -ln x over 2. And then e to the ln x, we can cancel e in the ln route. We get x minus e to the -ln x, just going to be 1 over e to the ln x. Again, e to the ln x, we can cancel e and ln out. We get 1 over x over 2. So let's simplify it. X over 2 minus 1 over 2x. That is our equation now. So y prime, the derivative of this, what's the derivative of x? It's just 1 over 2. Minus derivative of 1 over 2x. That's more difficult, but this is easy. So this is 1/2, then x to the -1. Put the negative onto the side and subtract by 1. So it's going to be -1/2 x to the -2, right? So negative here, negative there, it turns into positive. And then 1 over x to the -2 is going to be on the bottom, x squared. That's our answer. It's much cleaner to look at than if it was done with chain rule and whatnot. And it's equally as valid. So there we go. Question number 9. Y is equals to AR hyperbolic tanh of x cubed minus 1. I like this question. So, what's the AR tanh again? So, refresher, AR tanh, a derivative of this is equals to 1 over 1 minus x squared. Alright? So, let's put x cubed minus 1 into the input, and then let's see how it goes. So, we get y prime is equals to, let me erase this one so we can have room, 1 over 1 minus then x cubed minus 1, and then multiply by the derivative of the inside, which is going to be 3x squared. All right, don't forget the square here. Okay, can we simplify this further? Yes, we can. How? Well, look at this. 1, it can be expressed as 1 squared minus something squared. This is another difference of 2 squares. So difference of 2 squares, refresher again, x plus y, x minus y. That's the difference of two squares. Okay, so let's do that. On the top, 3x squared. On the bottom, 1 here, then plus x cubed minus 1. Then 1 minus x cubed, and then since it's minus, it's going to be negative negative, which is positive 1. So we get 3x squared over 1 minus 1 cancel each other out. This is x cubed now. And then 1 plus 1 is 2 minus x cubed. So this is x squared, okay? This is x cubed here. We can cancel the x squared out. We get x on the bottom. So 3 over x, and then 2 minus x cubed. That is the final answer. Good. Next. Oops. Sorry. Question number 10. Y is equals to natural logarithm of area hyperbolic cotangent of not x, sinh of x. Now a trick here, if you don't know what to do, because this is a long like equation, right? So why not do implicit instead? That's much easier. Then we can solve everything else later. So here you go. To remove ln, we raise e to both sides. Ln and e cancel each other out, so we get e to the y. So e to the y is equals to ar coch of sinh x. Oh, that's a mess. I don't know why that happens. Sinh of x. To remove the inverse hyperbolic cotangent here, we can put hyperbolic cotangent on both sides. Like this one and this one cancel each other out. We get hyperbolic cotangent of e to the y is equals to sinh of x. Sinh of x. All right. Don't mind the h. Anyway, so this is much easier to work with because well, there's no mess here. So we can start finding the derivative here. On the left side, hyperbolic cotangent is the derivative is negative cosecant squared, then the input is e to the y, multiplied by the derivative of the inside, which is going to be e to the y, multiplied by the derivative of y, which is dy over dx. Or if you like, let's just put y prime here. Then sinh of x, the derivative is just cosh of x. So now what we can do is what we can do is to, well, this hyperbolic cosecant doesn't do me any favor. I want that gone. So how can we do that? So we know hyperbolic cotangent squared x minus hyperbolic cosecant squared x is equals to 1, right? We can isolate hyperbolic cosecant squared x in order to get cosecant hyperbolic squared x is equals to hyperbolic cotangent squared x minus 1. So we can use that. So we can put negative and then hyperbolic cotangent squared and then e to the y, which is the input, and then multiplied by e to the y outside here, and then y prime is equals to cosh of x. So let's isolate y prime now. Y prime is equals to cosh of x over let me just hold on. I just move this one. So cosh over coch negative coch squared e to the y times e to the y. Now there's e to the y stuff in here, sorry. So there's e to the y stuff in here, so that's not good. So what we can do is to refer back to the original one. Coch e to the y is equals to sinh of x. So we can turn this into sinh squared of x, and then later we can put the, where is it? Uh, for the e to the y, we can put the arc coch of sinh x there. So I will put that now. Jeez. So it's equals to cosh of x over, and then negative sinh, god man, sinh squared of x. Then e to the y is r coch, and then of sinh of x. Let's simplify this even further. So we can put negative coch here, cosh over sinh, and then 1 over sinh is hyperbolic cosecant x over ar coch of sinh. God, hate that. Hate when that happens. Sinh x. And there we go. That's the answer. Okay, for question number 11. Oh, another parametric situation. X equals sinh of u, y is equals to cosh of u. We need to find the d squared y over dx squared. So first we need to find dy over dx. So before that, we need to find dy and then dx. dy is the derivative of this one, so this is going to be sinh of u. For dx is going to be cosh of u over this is going to be tanh of u. So we need to find the derivative of this one first over du. So what's the derivative of tanh? That's going to be hyperbolic secant squared u, and in order to find the second derivative, we need to find this, the derivative of dy over dx over dx. So we have hyperbolic secant squared u here, and then we have cosine of hyperbolic cosine of u. In here, cosine of hyperbolic cosine of u, when it goes up, well, it could we could say this is the reciprocal. This is sinh in the bottom. So we could say this is sech, sorry. So hyperbolic secant squared u times secant u hyperbolic secant u. So we get hyperbolic secant cubed of u. That's the answer. Feel free to look around while this is going on. Okay. So question number 12. So what's question number 12? We have two sets of equations. Theta is equals to cosh of 2x, and then y is equals to ar sech of 2 theta. We need to find dy over dx. We're going to do it two ways. First way, we're going to do it in a normal, and then second, we're going to use differential equations. It's very simple, so don't be scared. So let's use the normal way. So the normal way entails that we have to make y equals to something, a function of x. So we need to substitute the theta here for the cosh 2x. So ar hyperbolic secant of 2 cosh of 2x, correct? So we get, and then we get the derivative is equal to 1 over it's going to be 2 cosh 2x square root of 1 minus the square of this. So wait, let me check. Let us check if that's true. Yes, it's true. So 1 minus x squared, so minus 4 cos squared 2x. All right. Multiplied by the derivative of the inside, which is going to be 2 sinh. That is not sinh. All right. I apologize. Sinh of 2x. Then multiply it by 2 again because of the chain rule. So the two in here cancel each other out. The sinh and the cos, this now becomes 2 tan of 2x over sinh over cos is tan over square root of 1 minus 4 cos squared 2x. As far as I know, that's the answer. So that's the normal way. You can do it normal way, right? So how about the differential equations way? This is more fun. Again, theta is equals to cos of 2 x, and then y is equals to ar hyperbolic sec of 2 theta. So what we're going to do? So we're going to find everything with respect to x. So derivative of theta with respect to x is d theta over dx. And then cos of 2x with respect to x, the derivative of that is going to be sinh, sinh 2x, and then we multiply by the derivative of 2x, which is going to be 2. And then we find dy. So dy over dx is equals to ar sec to theta. So ar sec is going to be 1 over 2 theta, the square root of 1 minus 4 theta squared. That's the square of 2 theta. So multiplied by the derivative of the inside, which is going to be 2, then derivative of theta, which is d theta over dx. Cool. So we got d theta over dx here. Let's start replacing everything in here with the d theta and then theta. So y is equals to d theta over dx is going to be 2 and then sinh of 2x over 2 times theta, which is going to be cos of 2x, square root of 1 minus 4 times the theta squared. So theta is cos squared 2x. Then multiply by 2 here, so don't forget about that. So 2 with 2 cancel. Sinh and cos became tan 2x. And then there's 2 here, so we put that here. Over square root of 1 minus 4 cos squared 2x. And we got the same answer. So that means we can be confident that this is the correct answer since we answered it using 2 different methods. Alright? So that's it for now. Thanks for watching.